the wireless business at TI. And what we want to do today is we want to talk a little bit about some of the exciting things that are going on in the marketplace, some of the great progress that we're making. This is a really, really exciting time in the industry, and I'm really pleased that you're here with us today to see what we have to show. So let's just start with some of the things that have happened from a momentum standpoint. Since we were together last, we have been really, really busy. You look at some of the products that I'm showing up here. These are some of the great new phones that we have worked so hard through the course of the year to help our customers get into volume production. You see the list here, the Samsung Galaxy S2, the Motorola Droid Bionic, Samsung Galaxy Nexus, the LG Thrill, today the LG Optimus, or yesterday maybe the LG Optimus 3D Max, the Huawei Ascend P1 and P1S, the Motorola Droid Razr Max, and the Sharp Aquos. So really great. This is just a small sampling, but this at TI is something that we're very, very focused on. It's not just great enough to have great technology. What we have to do is be able to work with our customers to get those technologies into production. We've also been busy past smartphones. If you look at a lot of what we're doing, one of the things we're so excited about is we see great opportunities for these products in a broader set of markets. So if you look at some of the work that's been done this year from a tablet standpoint, we've got some really exciting customers in volume production this year from tablets. And tablets have been one of the hottest marketplaces over the last couple of years, and we're really, really pleased with our progress. You see tablets up here from a host of OEMs, including Amazon, which is a great example of where we think things are going, the role that the web and the cloud are going to play in terms of different kinds of services, and I'll talk about that a little bit more in a moment. You see the Fujitsu Aros tablet, Panasonic, the Motorola Zyboard, the Lenovo IdealPad, the Arcos series of tablets here. We're featuring the G9, Barnes & Noble across multiple generations of their tablet products, and Toshiba. And the Toshiba tablet won Best of Show at CES, so we're obviously very, very pleased to have partnered with Toshiba and worked with them on that. So a pretty good stable of things past smartphones in terms of what we've been able to do with tablets. But again, it doesn't stop there. You look at some of these new applications, and you think about what could be as we start to see these types of products being leveraged by a broader and broader set of customers in a broader and broader set of applications. A couple just to highlight from it. The always innovating HDMI dongle, which you can see over in this little living room setup when we break. That basically plugs into the back of any TV and turns it into a smart TV. Really a revolutionary product based on OMAP and some of our connectivity products. The Sirius XM links, again, another discontinuity here. Satellite broadcast now leveraging OMAP class products in terms of bringing things to market. The Parrot drone, very interesting kind of a product. This is a product that actually works like a helicopter, has a series of propellers that allows it to hover and move around, has a camera on the front of it, and you control it with your smartphone. So again, really interesting kinds of new applications for OMAP. The Nest Labs thermostat, another great example of a new kind of product. We all have thermostats in our house. This is a revolution in terms of that kind of capability. It's been designed with both OMAP and our connectivity products in it. The Moto Active, starting to see the increasing role that devices that work with the billions of smartphones that are out in the marketplace. This is a health product based on OMAP that connects to the smartphone and allows you to take care of yourself and make sure you're exercising enough and chart your progress. The Recon Mod ski goggles, we don't get a lot of call for those in Texas, but I understand that there are a lot of places around the world where people ski. Really revolutionary kinds of capability to understand where you are, tell you your elevation, and do lots of other interesting things. Raymarine Hybrid Touch, a next generation of marine navigation kinds of capability, again based on OMAP. And lastly, QNX did a really extensive demo out at CES last month, where they actually showed a Porsche 911 with 5 separate displays in it, showing kind of the next generation kind of capability that's coming to automobiles. Really spectacular, and it also won Best of Show at CES. So you step through that amount of momentum and all of that progress since we were together last, and we feel really, really good about the momentum. But we're not stopping there. I think that as we look forward, there's really a huge opportunity in front of us, and we see this world changing even faster as we move forward. than it's changed over the last 10 years. Specifically, you start to look at the role that cloud computing is going to play in the kinds of devices that are done and the kinds of things that you and I use. We believe that this is an explosive opportunity. I want to introduce a concept here of a digital hub. And this digital hub, I'll put some names up here so everyone can see. I think these names are familiar to people, but think about those companies, think about the services they provide, think about the strategies they have to go to market, and now let me try to put this digital hub concept into context. The first thing that these digital hubs do is they leverage the cloud for new user experiences and new services. So they're trying to come up with new and exciting ways to reach us as consumers. Number two, they make an investment in a server infrastructure. They own and control that server structure because it's core to how they deliver products and services to market. Number three, they own a wide variety of content. It can be audio content, can be as in music, it can be video, it can be ways to purchase things, but they own and control a lot of content that they use those servers to deliver to you and I as consumers. They want to deliver these capabilities to customers more and more broadly. Historically, this has been a PC kind of a world, so a lot of these services were deployed there, but we've seen aggressive trends where that's now in smartphones, it's in tablets, it's in cars, it's in home, et cetera, et cetera. And this is, we believe, a fundamental change that's happening in the industry. And the last bullet that I've got up there in the cloud is, I think, the most important. The other thing that we see is that these digital hubs will get more and more involved with picking the platform that they want to try to deploy those services. So that's a very, very important point. And that really ties to what we're doing at TI with OMAP. We believe that application processors are going to become the heart of a very, very broad array of devices driven by things like this digital hub. And we believe we're in a unique and unbeatable position in terms of the strength of our position with OMAP. So let's talk about OMAP 5. People can see here today we've kind of got everything featured around OMAP 5. We announced that in years past. We're here today to demonstrate it. We believe that it is revolutionary in terms of its capability, and most of what we're showing here, the biggest theme we're showing is all the great capability that that device can deliver to customers. And I want to spend a couple of slides cementing some of those concepts for people. If you look at what we're doing in OMAP 5, first of all, it is about a different kind of experience. The experiences are changing. It's about the graphics and immersive nature of the experiences that we can deliver to customers. If you look at what we can do, and this is important, most of the devices that we talk about in this increasing breadth, you're still operating in a mobile environment. You're still operating where you're probably using a battery. So the thermal considerations are critically important. And we believe that the OMAP 5 platform can deliver significantly more capability inside of that power envelope. In fact, we say 33% more performance inside of a given envelope than what our competitors can do. That's effective MIPS that can be applied to whatever the application is. Number two, we talk about these more immersive experiences. We talk about the role of graphics. We have a significant advantage in terms of graphics, 4x the graphics capability on this device versus the competition. And we think as you see things like ice cream sandwich moving more and more toward graphics as the center of those systems, and all the fancy things that people are doing with software and games and applications, graphics is key, and we think we've got a significant advantage here. And lastly, we've also added, in addition to just the graphics cores that are in the architecture, we've got a composition engine. And what that basically does is that allows you to offload a lot of the UI tasks to that composition engine where you can do it much more efficiently than it can be done on the graphics core. So it's about 1/10 of the power to render the UI of what you would have to do if you did it on the graphics core. So again, a very specific approach that we take to solving these problems. Everything that we do is in a power and inside of how do we get the maximum amount of performance at the lowest possible power. So I want to spend just a couple of more minutes on this because I think it's really important. If you go around the show or you spend any time in the industry, everybody is talking about number of cores and clock rate and everything else. And if you spend time at Texas Instruments, we will talk about the same things. But the way we talk about it is, again, inside of that power envelope. So what we've done, what we've been focused on is this concept of a smart multi-core architecture. How do we take this very complex chip, and I've got a map of it here and I'll spend a minute describing it, but how do you take that combination of all those elements and optimize that specifically for the application, driving more performance within a very low power envelope. So what you can see here is just to show you some of the things we've got inside OMAP 5. We have two Cortex A15s, which is the latest and greatest core from ARM. We picked those cores over a quad-core kind of a solution because of what they could do in terms of how much performance they could yield at the power. And I'll give you a very concrete example of how that manifests itself in a real use application in a minute. We also use some other ARM cores to control some of the video accelerators and other tasks where we offload the A15s. We've got dedicated hardware for a lot of the imaging and audio and video acceleration tasks. We have a DSP inside of this platform. But again, what you look at here inside of this big chip that you see to the just to the left of this chart is you see a smart multi-core architecture, a balanced approach to solving the highest possible performance at the lowest possible power. If you look to the right, what you see is something that I believe we have unique capability in. We bring the rest of the components that are critical to that system for those customers. So when you think about the power management unit that goes alongside the application processor, when you talk about a discrete audio chip inside of that, we have solutions for that. When you talk about connectivity, which is very, very important for all the different ways that these products can get connected past the WAN. And you see the last box here with the modem. We work with our modem partners to pre-integrate those modem solutions, and all of the things that you saw up there in the smartphone context were brought to bear through that kind of a partnership with external modem guys. And I'll also stress here that there are an increasing number of those systems that I walked you through, either tablets or in these extended markets, that don't even need a modem, that are going to connect in a different way. So we're really excited about this and think that this is absolutely at the core of our differentiation. So what I want to show you now is I want to show you a video that we pulled together that really, I think, cements the fact that OMAP 5, when we talk about what really matters, not a bunch of specs, but we talk about what really matters, which is a concrete use case, that OMAP 5 is clearly differentiated. So I'm going to run you a video that we actually have available on YouTube, and this is a video that we put together. It takes the OMAP 5 that we all know and love, and it compares it to a commercially available quad A9 device from one of our competitors, and we did a side-by-side comparison. We used an industry standard benchmark called MWC, and basically what that MWC does is it goes through and it asks these platforms to do 20 very complex page renders. So it's all about HTML5 and how quickly you can render those things, and this benchmark is going to go through and do a series of 20 of those page loads. The other point I'll make is if you hear over the din that we have, you'll also hear audio running. The other thing we added to this benchmark was the fact that we had to play audio back. And what you can't see here is that we're actually doing a video decode as well in the background. So both of these platforms are doing exactly the same thing.
Is certificate in video or the old smartwatch?
What?
We're not. Smartwatch.
Please hold the question. So anyway, you basically can see what's happening here and can see the difference in terms of speed. Look at the bar down below. The red bar is what's happening on OMAP 5 and its ability to progress through those 20 complex page loads. And over here in white, you have the competitive platform. Again, the other thing I'll tell you is that this, on OMAP 5, the CPUs, the A15s, are only running at 800 megahertz. And on the A9s, the quad A9 architecture, each of the cores is actually running at 1.3 gigahertz. So you see a pretty significant difference here. And you can see OMAP 5 is in the home stretch. Page 18, page 19, and page load 20. So in 95 seconds, we got through that very, very complex benchmark, and we'll wait a little bit longer for the quad A9 to catch up. What's important here is that there are a couple of things. Number one, we picked the A15 core because we felt that it had a significant advantage over what the A9s could muster. That's point number one. Point number two is if you look at the nature of a lot of these applications, something like HTML5, what you'll find is that it's clearly dominated by more of a single-threaded kind of an application. so that the number of cores actually don't render in increased performance. Number 3, the details of that smart multi-core architecture. The details, the intricate details of our memory subsystem, the memory architecture, how we do caching, how we get on and off chip, those things all fundamentally are more important than what's happening in terms of the multiple cores or the clock rate. I'm sorry, I'm out of things to say, but they keep going. I'm going to have a drink of water. Page 17. Page 18. Really hard to wait, isn't it? Page 20, home stretch, 201 seconds. So I think this is the reality of where we are. And this is what our customers see, and this is what's most important. This is what we all see as consumers. So again, our focus is the best technical solution to try to solve the problem of bringing great next level performance to these kinds of applications in real user use cases, and then doing that at a very, very power efficient way. That is the core of what OMAP 5, OMAP 4, OMAP is all about at Texas Instruments. So with that, let me shift gears and try to cement this a little bit more. We talked about a little bit about this foundation, and hopefully I've shown you a little bit more about what we're doing with OMAP and why we're so excited about it. We believe it is the best application processor on the planet, bar none. Number 2 is when you start to look at that platform combined with the role that these high-level OSs are going to play and the strength of our positions with those high-level operating systems, we believe we've got a great combination there. Add one more thing to it. Add this increasing breadth of where application processors are going to be used, and I think you see an unparalleled opportunity for Texas Instruments moving forward to bring this capability to market and continue to lead the market. I've got 2 examples that I'm here to announce today about a couple of things that cement the concept. One is a company by the name of Harman, and I'm not sure how many people know Harman. It's a big company, and they actually have about 15 different sub-brands underneath the Harman umbrella. You think about Harman Kardon, you think about Harman Becker. It's actually a big company with a lot of different brands. They have decided that they were going to use OMAP 5 as their de facto platform to go off and drive the next generation of automotive systems, both for in-console as well as these centralized multimedia centers. So they're picking this platform. They work with OEMs around the world. Those Harman systems are in 25 million cars that are driving around today. It is a very, very significant design, and it's a very significant partnership that we are very, very excited about. If you look at the details of why did they pick us, they picked us for all the reasons that I just went through. They picked us because of that smart multi-core architecture and all the benefits that it brings to the table. Specifically, when we talk about OMAP 5, the things that they valued were the premium graphics, the premium video, the fluid responsiveness, and the unmatched scalability of that platform and where we're taking that over time. So we're really, really pleased about that one. The other one that I have to announce today, I don't have a graphic because, frankly, it is so recent that we made a decision. The press release will come later in the week, but it's a company called iRobot. And if you notice on that one circle chart that I pointed, there was robotics was one of the areas that we've been working hard at. iRobot has decided to use the OMAP platform in their next generation robotics, advanced robotics, specifically for visioning and analytics. And you start to think about the role that vision and analytics are going to play. And again, we believe that that's a core value that we can bring with OMAP and something that's going to be increasingly important across a broader and broader set of customers. So in summary, a couple of points to leave you with. Number 1, we believe we have incredible momentum. If you think back to where we were a year ago versus where we are today, the kinds of products that I've showed you across smartphones, tablets, and some of these new markets, I think we've got great momentum as we go into this accelerated change in the market. Number two, without question, OMAP is the best application processor. We prove that every day to our customers, and we'll continue to stay focused on that. It is the best application processor in the marketplace today. You combine that with the fact that I believe we have a unique capability at TI to surround the rest of those systems. You think about what we can bring to those systems in terms of connectivity technologies. Think about what we can bring with some of the great things we're doing with our DLP technologies. Think about what we're doing in power. Think about what we're doing in audio and the rest of the signal chain. Think about what we can bring in microcontrollers. There is no other semiconductor company that is capable of solving that class of problems across those boards other than Texas Instruments. And lastly, and very, very importantly, as we start to talk about the breadth of applications and customers, we've got the biggest sales force. We have over 2,500 salespeople deployed around the globe, calling on our customers every day, designing this technology in. We could not be more excited about the opportunity we have in front of us, and we really appreciate you attending today. I will transition. We have some folks in the audience that I'd like, if they can see me or hear their name, if they can raise their hand. Again, my name's Greg DeLoggy, and I manage the wireless business. I'll be around to answer any questions folks have. Remy Elouzain, where's Remy? Remy's up front. Raise your hand, Remy. Remy manages the OMAP business at TI and knows all things OMAP. Habib Alan is back here as well. Habib runs our connectivity business. So we announced the Y-Link 8 product a couple of weeks ago. We've got an exciting new SimpleLink family to attach everything on the planet with our connectivity technologies. Habib can talk to you about that. Kent Novak, we've got them all standing back here for some reason. Kent Novak manages our DLP product line at TI, so he'll be happy to talk to you about DLP. Brian Glinsman, the one guy he's our infrastructure guy. Brian manages all of the communication infrastructure products at Texas Instruments. Sammy Kiriaki, Sammy is here. Sammy manages all of the power products at TI. Steve Anderson is not here. Steve Anderson is not here. He manages our power products. We've got people that are around that can answer any questions you've got about what we're doing in power technologies. And Dave Heacock, last but not least, manages our high-volume analog business, and we'll be happy to take any questions. So with that, I'll wrap up. Thank you all for being here today, and we'll be happy to answer any questions you have. Thank you.